These are the bits that identify what? The clock cycle. So they go from 0 to 1 to 2 to 3 to 4 and so on and so forth, right? They are for now a placeholder opcode. अब इसकी वजह क्या है? इसकी वजह ये कि जो मेरे पास मैंने अभी जो 8 बिट का साइकिल लिया है, in this specific instance I've just used a dummy opcode of 0000 and I'm using. मेरे पास इस वक्त मसला ये है कि जो मेरा सर्किट, जो मैंने रोम का सर्किट इस्तेमाल किया है, उसमें जो मेरे पास एड्रेस बस है वो 8 बिट की है. And my guess is I can use 5 bit का opcode and 3 bit, but that means that I need to execute each cycle or each instruction in about 8 sub instructions. So if I can do it in 8 sub instructions, I can use the 5 bit का opcode and I can use the 3 bit का clock cycle. So ये जो दोनों का combination है, opcode and clock, this is what would essentially become your micro program for the program controller. So if you look at the structure below, ये जो 9 instructions है मेरे पास यहाँ से लेके यहाँ तक, this represents the addressing scheme. And in this addressing scheme there are two parts. The first part, the most important part for us, is the sequence. And what does the sequence do? The sequence tells us that first clock cycle do this, second clock cycle do this, third clock cycle do this, fourth clock cycle do this, fifth clock cycle do this, sixth clock cycle do this, seventh clock cycle do this, right? That's the first part. I'll just call it and label this as A. The second part of this addressing scheme is the opcode. And right now that opcode is 4 bits, but don't worry about that. You can easily switch it to 5 bits later on. That's not an issue. For now, I think what we're trying to do, we're trying to get a sense of, once we get the addressing scheme right, what happens next. So if I have the addressing scheme right, then from my perspective, what I then need to figure out is that all of these signals that I've identified mapped to these specific bits, these are the desired values that need to be generated. And in this specific instance, what's going to happen is, ideally speaking, from here to here, how many clock cycles is this? About 9 clock cycles. In 9 clock cycles, I would have taken the data, I would have moved it from the RAM to the ALU, and I should have been able to bring it back to the RAM and store it. If this program works, and it works as it's supposed to work, then what happens if you have a different opcode? What will change? क्या चीज़ change होगी? So let's say this is a simple load instruction. This says, load memory test, and the opcode is 000. And let's say the opcode for add is 001. So what will change? What do you need to change to make it work for add? So you have to remember, for most operations, the key part, the common part, the basic part is the same. The basic part is what? Fetch data. Is that going to change from operation to operation? Will that be different from add, subtract, multiply? It'll be the same, right? So fetch will remain the same. Okay, so now what will change? If fetch remains the same, what will most likely change is that you would, for example, rather than just having one operator, let's say if I have the ALU where the data is going, I would have to tell the ALU this is the opcode, so please perform this specific operation. And then the ALU will then react and respond accordingly. So there'll be maybe 1 or 2 signals that will change. And how do I know what to do when? So as long as I understand that, let's say, so if I change this opcode right now, this opcode is 0000. Let's say if I change it to 11111, so it becomes 1111. What happens? Only this part will change. These clock cycles and the relative action that's happening with respect to those clock cycles will remain the same. Within some of these clock cycles, when you talk to the ALU and you tell the ALU add or subtract or mult, the relevant opcode would be different. That will actually pass through the signals. But other than that, everything else will remain the same. So it's important to get the fetch cycle working and to sort out and reduce and simplify and optimize the fetch cycle for, let's say, a dummy opcode. And then you'll just replicate it again and again and again with some minor changes and tweaks. So unfortunately, you'll all have to do it yourself, right? And some of you will make the same mistakes that I did, and then some of you will be medicated, some of you will be taking Advil or Telfast or paracetamol. You can't you cannot make a generic prediction whether it'll get done in a day or 2 days. But if you get caught with something, or something goes wrong someplace, then you'll have a challenge. Our next stage or next step on our part is that we convert these numbers, as I explained earlier, into the hexadecimal equivalent numbers, and then we go set up. So I'm going to switch to Logisim. Remember that Excel file that I generated? Those list of words that you have, the hexadecimal words. How did we get here? ये कहाँ से आया हमारे पास? So if I go switch back to Excel, the easiest way of doing this is that once I have the relevant hexa, I just select these. So that's my 8 lines, copy them, and then you can use a simple utility like Notepad. So I use Notepad. Go to Notepad. I'm just going to create a new file, new tab. Call this my ROM. Alright, so my ROM Sunday evening has been saved. So what I've done is I've just copied the values that I'd saved that I copied from Excel into a Notepad file. And on that Notepad file, you see this ROM Sunday evening txt.file. Okay. And on the ROM, so select the ROM, and you can just do a right click on it, and it'll open up this option. Then you do load image, ROM Sunday evening. There you go. That's it. That's all you have to do. Once you do that, it'll open up this screen for importing. I've picked v2.0 raw. Press OK. And my ROM now actually has the word. So you don't have to type it in. You can just load it. You can do the same thing with memory, right? So for example, if I want to run this specific simulation, 03FF, right, which is my instruction RAM. And then for A, I actually have an image stored, so I can just load that image also. So I do a load image, RAM A dump 3. There you go. Then I repeat the same thing for RAM B. I have a load image for RAM B also. So now my simulation is set up to run because all the RAMs and the ROMs have everything available. ROM, I think you just need to load once. Once you load it once, it'll stay. RAM, you'll have to update it. So now everything is set up. What do you want to do? So now what you want to do, you'll set it up for simulation, right? So now simulation mein auto tick frequency mein aapke paas choices hain. So click on simulate and then go to auto tick frequency, and then within auto tick frequency I've picked 1 Hertz. 1 Hertz is slow enough for me, so that I can trace it, and I can also track it, and I can also see what's happening. You can do it faster if you're in a rush. You can do it slower if you need more time. So I set the auto tick frequency at 1 Hertz, and then I'm going to turn auto propagate on. So either auto propagate ko on kar dein, and then iske baad aakhri thing that you have to do is turn auto tick enable. But I'm not going to do that right now. I'm going to actually move and make sure that the circuit is at a point where I can see it. So those are my RAMs, and then these are my MBRs. Okay. And what we want to do now is I'm going to reduce it a bit so that we can get a fuller view. Mars, that's my instruction splitter. These are my banks, and this is my MBRZ. Okay, so far so good. Are we all right? So now I'm going to run this simulation just once, turn it on, and you've seen what I've done on the ROM. The ROM's going to feed the control lines. The control line's going to do everything else, and this will be done essentially on an automated basis. So I'm not going to touch the circuit other than setting it up to run based on the values that I've picked up for the RAM and the ROM. So I'm going to turn auto tick enable, and the clock cycle will run step by step, right? So now what do you want to watch? You want to watch, first keep an eye on MAR0, then keep an eye on MBRZ, then keep an eye on MAR-A, then keep an eye on MBR-A and MBR-B. So you can see MBR is 01. ये filter update हो गया. Look at this, MBRZ में already 03FF आ गया है. MRA भी इधर 1F आ गया है. यहाँ पे हमारे पास register के अंदर A और BB आ गया है. How long will that take? Now you can also see that there is a conflict here, right? So अब conflict कैसे आया था? लाल लाइनें सारी लाल हो गई थी. तो अब हम कितने स्टेज के ऊपर आए? How many clock cycles have gone through? So we have the values A and B, right? But we don't have values here. So यहाँ पे क्या हो रहा है? अच्छा, अब अगर आप इसको चलने दें, यहाँ पे चल रहा है, इसको चलने दें, and then go back here. So has there been a change in the status of RAM A or RAM B? No. Has there been a change in the status of the RAM here? If you see here, इधर आके देखें अगर आप, तो you can see कि ये 03FF वही है, लेकिन इस वक्त RAM कौन सी चल रही है? ये 15th cell के ऊपर आ गया है. And now it's gotten to 1E and now it's at 1F, right? This is, where is this coming from? This is coming from the counter. Now it's back to 03FF. And similarly, if you come down to the ROM, look at what's happening to the ROM. So अगर आप ROM में भी देखें तो यहाँ से program counter, जो ROM का clock counter है वो चल रहा है, and it's just basically going to cycle it through, right? So it'll go to the first 00, then 01, then 02, then 03, then 04, 5, 6, 7, 8, 9, 10th. 10th instruction पे will then roll back all the way back to the first one. So now I've stopped the simulation, I've reset, and I haven't stopped it. Auto take enable off कर दें, इसको reset कर दें. अब जब मैंने reset किया तो what has happened? Do you see? Well, the image hasn't changed. Image has remained the same. And if I go to my RAMs, RAM में इन दोनों को मुझे दोबारा से load करना पड़ेगा. So I'll just shift this to 03FF, which is my dummy instruction, and just load the image here. Load the image here. ये दोनों images load हो गए और अब आप इसको वापस जाके set कर दें. No, it's not because there are only 10 instructions. It's because I've set the control cycle in such a fashion that it resets, it goes back. अच्छा जी, तो अब जब हमने ऊपर काम किया ना, यहाँ जब हमने काम किया, ये तो हमें नज़र आ गया, right? Now the question is कि ये जो नीचे काम हो रहा है हमारे पास on this side with respect to ROM, यहाँ पे क्या हो रहा है? ऊपर तो आपने देख लिया, you've seen how things are moving on the top side. How are things changing as far as the ROM is concerned, and how is it feeding the signals that are going out? So what all it's doing, it's given the address. So this is the address that you give it. Given the address, it picks up the relevant value and it feeds the line, the signal the lines need, and then it moves on. So I'm now going to run it again one more time, auto take enable with a lower frequency. So ये पहला clock cycle आया, ये दूसरा आया. You can see the counter here. This is now 1, then it becomes 1, 0, then it becomes 1, 1, then it'll become so on and so forth, right? And based on the relevant signals that you've picked up and pointed out, it'll feed the signal to the right line, and those lines will go out and do what needs to be done. And if you change the opcode, all that'll do is go on to a different address. So if you look at here right now, it's given you 256 lines. So now, right now, with this specific ROM, with the address bus that I have 256 lines. If I need more lines, then I need to either add a bigger ROM and a different address bus. ये पहले the cycle हो गया आपके पास. You're done. Obviously now the problem is this will only get to a point where you can get the data and feed it to the registers. Actually stopping just before the registers, and at the registers there's a conflict, and that's the part that you have to figure out. But I hope that by now you have a sense of how everything comes together. सब चीज़ें साथ में कैसे चल रही हैं. No, Fatma, you don't give ROM. अगर आप यहाँ पे देखें, इधर देखिए आप, यहाँ पे क्या हो रहा है. So this is the current opcode. Where is the current opcode coming from? Where do you think it's coming from? इसमें जो value आ रही है कहाँ से आ रही है? Where is this value coming from? So we're not manually feeding it to it. We're actually coming from a place. Yes, that's where it's coming from. So if you go back, if you trace this out, if you trace this line that you're trying to sort of come through, this is where it's coming from. It's coming from this side. So यहाँ पे I have this thing called current opcode. I have this line called current opcode. And that's the line that's going all the way down to your ROM. This is that line. Does it answer your question, Fatma? What about the process that sends instructions to the splitter? How do we automate that if ROM wasn't working before that? No, ROM is working. So what's the first address in the ROM? So if you go back to the ROM, what's the first value in the ROM? 000, right? That's where it starts from. So it doesn't do anything with 00. And then you've got the first instruction, and that first instruction assumes, okay, there is a value in mar. Now, what is that value in mar? Let me just stop the simulation so that we can go back to it. I'm going to turn auto take enable off. you have to take a look at what is the initial opcode and how does things start. So initial opcode, if you see, it says 00 here, starting off with 00, right? And if it starts off with 00, and there's a buffer here also, so maybe the initial state, this will turn this on, and then set this to 00, and then pass that on, and then mar will execute. But for the first instance, so very first instruction, whatever that instruction is, you will start off with assuming that that's just an initial fetch, and you can just write, just like you've written all other lines, you'll just write those lines too. So अगर आप यहाँ पे देखें, this program counter, this is the program counter that basically walks through the RAM, walks through the instruction RAM. Do you see the values that are here? If you set up the values, so if you go back to get out of the poke mode, if you look at this specific RAM counter, right, you see it says maximum value is 1F, so it'll run till about 16. It'll read 16 values. Sorry, from 0 to 15, right? That's all it'll do. If you go to the counter that I'm using for the ROM, नीचे, what do we have there? यहाँ पे क्या है हमारे पास? If you select this one, you'll see that maximum value is 0B, right? So 0B is what? It's 11 values. And then if you see action on overflow, it's wraparound. So it'll turn it back. It'll go back to 0 and start from 0 again. ठीक है? Make sense? Asad, did it answer your question? A flag अभी हम इस्तेमाल नहीं करें मनाहिल. Opcode register output is going here. It's going here. यहाँ आ रही है. There you go. That's where it's going. Alright ji, so I think that's all I had. I think my hope was that this would help you understand कि आपकी sequence क्या है और आपने काम क्या करना है. The letters in hex, what do they mean? They're just a binary representation. Rather than typing zeros and ones, all I have to do is just convert them into hex, so that rather than typing in 32 ones and zeros, I just have to type in maybe 6 or 7 letters. Oh, F is, oh, achha. So, okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. ये तो आपके पास है, ये तो कर लिया. So, आप 10th को कैसे represent करेंगे? आप 1, 0 को कैसे represent करेंगे in hexa? So, after 9, you get an A. 11 को कैसे represent करेंगे? That's a B. 12 को कैसे करेंगे? That's a C. 13 is a D. 14 is an E. 15 is an F. You can, so right now, you know, we've left it open for how you work with it. You can use it to store results, and you can do other things with it. There are certain operations that will require you to sort of work with the system RAM. So हमने एक खाली जगह रखी हुई है as a scratch pad के तौर पे. You'll most likely get the recording tomorrow evening, because I'm going to go home and sleep, and I have a full day of work tomorrow. तो कल शाम तक टाइम मिलेगा. पहली recording जो है, which is I think about 2 hours or about 90 minutes. So for every hour, you know, it takes about 6 to 7 hours worth of. So for any operation, what you need to think about is कि जब आप values read करेंगी, तो what is the most efficient way of reading that value? And जब आप, if you have more than one instruction in the pipeline, then what is the best way of making sure that that data is not lost or overwritten? And that's the reason why we use buffer registers. So the best possible path is that, you know, memory writes to the buffer registers, and then buffer register to the register, and the register to the ALU. And then the same path should be followed back if you think you have enough space. Unfortunately, in the architecture that we're using, it may make more sense for you to write from the ALU directly to the RAM. So that's a path that you have to figure out. मैंने अभी क्या किया हुआ है? मैंने सिर्फ एडर लगाया हुआ है इस वक्त. So मैंने सिर्फ एडर लगाया हुआ है यहाँ पे, right? So if I replace the adder with an ALU, what will change? अभी मैं सिर्फ A and B ले रहा हूँ, and that's all I'm doing, right? So what do I need to do? I need to plug in the opcode from the opcode register above. And what else? और क्या change करना पड़ेगा? So these are some of the questions that you have to think about. I think हमारा आज का ऑब्जेक्टिव बहुत सिंपल था कि आपको two things should be very very clear to you today. One is that once you figure out how to do this, it's not difficult. It's very tedious and it's very problematic because it's very very simple to make a small mistake, and that mistake can take you hours to resolve and sort. So you need time to do this. Two, it's best to just test it with one single operation and make sure that you've got the fetch, execute, store cycle working properly. Once you've done that and you've perfected it and you don't have any issues and errors and problems and bugs and conflicts with it, then it's a simple extension of simply adding the ALU rather than that simple operator and then making the circuit work again. Three, the best and the fastest way of building the control line circuitry is to do that in Excel and then convert that to hexa and then save it as a ROM image and then connect this to your ROM and then use that ROM as your program control unit rather than the design or the structure or the approach that we'd seen or that we'd shared earlier when we shared the David playlist. I think the David playlist is a great playlist and it does a really good job, but the ROM implementation of the PCU is a neater and a cleaner implementation. ठीक है जी, are we good? All set? So I think you have enough food for thought. Even अगर आपके पास रिकॉर्डिंग नहीं भी है, I think you now have, I hope that you have a path in front of you कि आपने अगले 3 या 4 या 5 दिन में क्या काम करना है. Answer Discord पे सवालात पूछे. There are TAs also available on Discord. So any questions that you have after this session, start posting them on Discord, and I think one of us will get back to them, once we wake up tomorrow morning. Raheem, I'm not going to break it down into a Niwala by Niwala breakdown of steps and executions. There is a lot of stuff that you have to figure out on your own. So आपको हर चीज़ के ऊपर guide नहीं मिलेगा. You have to make the 16-bit CPU work for the structures and the instructions that have been shared. You have to make it work with matmult. And then once you have all of this done, in the last week before the Viva, we will actually give you a test script. And then you have to make sure that that test script works on the circuits that you built. Okay, does that answer your question?